welcome to Verilog tutorial. In this session, we'll be getting equipped with the usage of ISC Project Navigator from Xilinx Design Suite. So with start, one can see this default layout. If not, one can click on layout and load default layout. So before starting with the new project, I have already created a folder in my drive with name collect Xilinx projects without any spaces. So let's click on new project, and first thing will be we'll change the location to the desired folder. Here we go. Then we'll add the name to the project and a small description. So here, out of various modes of entry and out of various hardware descriptions, we'll be first going with the schematic. And these are the project settings which we'll be seeing sometime later. We'll click on next. And this is, in similar context, the summary of the project. So with the click on finish button, one can see the design directory with implementation and simulation tab. So implementation, we implement the modules, and simulation, we test the modules. So here we'll right click on the board selected, and then we'll click on new source. Since we have already mentioned we'll be starting with the schematic, we'll select the schematic file and we'll name it with a unique identity so that it doesn't conflict with the internal files. So in this session, we'll be creating a very simple system of AND gate, 2 input AND gate. So here we can see the schematic canvas and lot of options popping up over here. So in this canvas, we can drag and drop the components or the systems from the library which is provided inbuilt. So we'll click on all symbols, and then we can search for any desired component. So we'll click on AND, we'll select AND to input, and then we'll select and click on the canvas, and then we'll right click or escape. So to zoom in, we can use the magnifying glass provided, or we can use control and the scroll button in the mouse provided. So now to create the inputs and the outputs, we'll be clicking on the input output markers. By default it is in automatic mode, but good practice will be to set it manually. So we'll set it as input marker and then as an output marker. So let's rename the ports. So we'll rename it as A and this as port D and this as C out. So the system is ready, but it is not yet saved. So we'll save everything. So once the module is ready, we can check for its design. So we can select the module and then we can go to design utilities and then click on check design rules. So since it is very simple system, it is already verified. Now to test the module just created, we can add a test bench, and here we'll select the Verilog test fixture. And good practice will be to start the name with test or TB. And we'll click on next. And this is the module which we want to test. So if everything is fine, we'll get a test fixture, something of this kind, with the inputs and outputs mentioned as registers and wires. And this is the instantiation which we'll be seeing in later sessions. So let's switch to simulation mode because we'll be testing the module just created. So this is the test bench what we have created, or the test fixture what we have created. And the unit under test is my hand schematic. So here we'll define some sets of inputs and we'll try to observe the outputs. So here we'll be using initial block, and since we'll be having multiple statements, we'll be wrapping the statements in begin and end statements. So just to make it readable, we'll add end and then we'll enter to the next line. To observe the response, we'll be adding some delays and then we'll change the inputs. So here we are adding a delay of 10 nanoseconds. So 10 nanoseconds, due to the reason the time scale defined up is in nanoseconds and the resolution is 1 picosecond. So for various other possibilities, and let me just show you the syntax error with what it throws. In case if you make any unwanted errors, it will point out to the location or approximate the location. So we'll add the semicolon and we'll save it, and then we'll copy the various other inputs possibilities. Just to make it more readable, one can add enter so that it looks divided equally. And in later sessions, we'll be appreciating the readability of the programs as well. So having done the appropriate input initializations, we are ready to simulate the module. So for that, we'll select the test bench and not the unit. So we'll select the test bench and we'll go to iSim simulator and we'll first check the syntax. So here we have green flag, which indicates we can go ahead with the simulation. So the outputs are obtained in the iSim graph or iSim program. So one can use this auto set, and here we can see the initial foldings or initial input or initial output variance. So we'll zoom in the nearest part and we'll just verify the inputs and outputs relation for the module just created. Since it is a minimum system and is a minimum system, so we can see the inputs, the output variance and the input. And since the extra part in the output display we want to truncate, so one can add a command to stop the visual. So to do that, we'll add a delay of 10 more nanoseconds, and then we'll add the command, which is $finish. So we'll save the file and then we'll check again with the test bench. So with that run, we'll get a tabbed button. So we'll click on default WCFG. So here we can see the truncated result or truncated display for what input variance we wanted. So here we have inputs and output relations. And while starting up with the simulations, the layout which we can see is something else. So let me just show you. So initially we'll be seeing something of this kind, wherein results are at the corner. But for few sessions, we may not be using the process directories. So we'll close it, and we'll keep the default layout to this.